You know that feeling, right? When an app you absolutely rely on, your bank, maybe, or a work tool, gets a big update. And you hit refresh and the whole thing just slows down. Or maybe it just completely fails. That feeling of chaos, that's what today's topic is all about preventing. We're doing a deep dive into continuous monitoring or common. It's basically the unseen process, the digital eye, that keeps the fast pace of modern software from just, spontaneously combusting.
That's a great way to put it.
Yeah.
Because DevOps monitoring at its core is really about overseeing the entire process. We're not just looking at the end result. We're talking about the whole life
The
cycle.
whole thing, from start to finish.
Yep. Planning, development, integration, testing, deployment, and of course, operations. The whole point is to get a complete, real-time, 360-degree view of your applications, your services, all of it, especially while it's live in the production environment serving actual customers.
Okay, let's unpack that a bit because it sounds a lot like really, really good quality assurance. But if the monitoring is happening in production when it's live, how is that different from the old way of just, waiting for an alert or a bug report to come in?
The key difference is this concept of a continuous feedback loop, or what we in the industry call shifting left.
Shifting less.
Exactly. Old QA was very linear. You test, you deploy, and then you wait for something to break. Common is cyclical. Of course, you have to respond to problems right now. But the critical part is taking that data, what's actually happening out in the wild, and feeding it back.
Back to the beginning of the process.
Right back to the earlier stages.
Yeah.
You take what you learned from a failure and you apply it to the next design, the next development sprint. You're actually proactively trying to minimize future problems, maybe by building better instrumentation into the software itself so it can detect and even automatically respond to errors.
So if I'm getting this right, we're moving beyond just fixing what broke. We're trying to architect software that's just inherently less breakable because it's constantly telling us how it's feeling.
Precisely. It's all about that real-time feedback. Think of it like the application's nervous system. It's giving the dev teams instantaneous information on performance, on usage patterns, while it's live.
This is where it gets really interesting for me because the goals here aren't some vague idea of stability. They are super specific, measurable metrics that are all about speed. When a team is trying to get to what they call high availability, what are the key time metrics they're trying to crush?
We're laser focused on three main time components. First, you have to reduce the time to detect a problem. We call that TTD.
Okay, TTD.
Second, you want to reduce the time to mitigate, or
Right.
TTM. That's just getting a temporary fix in place, a workaround.
Got it. Stop the bleeding.
Exactly. And third is the time to remediate, TTR. That's the permanent fix.
Can you kind of paint a picture of that? What's the difference for a customer if those three numbers, TTD, TTM, TTR, are small versus when they're huge?
Oh, it's a night and day difference.
Yeah.
Imagine some server goes down unexpectedly. If your time to detect is, say, 30 minutes, that's half an hour of your customers getting more and more frustrated. You're losing revenue. You're damaging your reputation. It's a disaster.
Or front page failure.
Right.
Right.
But if your comment is so good that your TTD is maybe 3 minutes, that's not a major outage anymore. It's a tiny blip, a blip that maybe only a handful of users even noticed. So by shrinking those three metrics, you achieve high availability. You prove your system is robust.
And that speed is just so critical now. I mean, teams are pushing out changes multiple times a day. With that level of change and complexity, it feels like this isn't just a nice to have. It's basic operational safety.
It absolutely is. And that need extends into what we call change management and dependency monitoring. Change management is the obvious one. Quickly seeing which new line of code or which configuration change just broke the application. But dependency monitoring, that's the real killer these days.
What do you mean by that?
Well, think about any modern app. It relies on dozens of other things, right? Third-party tools, external APIs, open source libraries. You have to monitor if you're using the latest version, sure. But more importantly, you have to monitor if those third-party tools themselves are vulnerable or slow or just plain broken. Good common is like getting a text from a worried friend the second a critical dependency starts to fail.
Because failure is just, it's guaranteed in these complex systems. Something is always going to break. A pipeline, a database query, something.
And that's where that proactive shift left idea really delivers. We're moving beyond just being production firefighters. We're applying that monitoring mindset way earlier.
How far left can you actually take it? How really can you start monitoring performance?
You can go pretty far back. It can start with something as simple as static code analysis during the build. That gives you early insights on code quality, potential security flaws. things like that, before it even gets deployed.
Okay.
But the real shift is when you start running your application performance monitoring your APM solutions in a production-like test environment. This is huge because it captures runtime behavior that static analysis just can't see. You're stress testing the app against what you expect it to face in production.
So you're not just seeing if the code works in a vacuum, you're seeing how it's going to perform under pressure.
Precisely. You get immediate feedback on its behavior, which lets you make corrections long before a real customer is ever affected.
Okay, so every organization needs this.
Yeah.
But the scope of what you have to watch seems overwhelming. Are we talking about dozens of different screens and dashboards, or is there a way to organize this landscape?
Oh, there is. We break it down into 4 distinct pillars. It's not one single activity. It's 4 complementary areas that give you that full coverage. You always start with the foundation. Infrastructure monitoring.
The bedrock.
Exactly. Your physical servers, your virtual machines, containers, storage, all of it. And since this is about raw power and capacity, the main metric you're watching is resource utilization, CPU, memory, that kind of thing.
And this is where tools like Prometheus and Nagios come in. Why are they so foundational for infrastructure?
Well, a tool like Prometheus, for instance, is built on a time series database. That model is just perfect for grabbing and querying the immense constant stream of data coming off of thousands of servers. It's built for that high volume machine level data.
Okay, so then we move up a layer to the actual software the user interacts with. That would be application monitoring. This is probably what most people think of when they hear performance monitoring.
Yeah,
You're right.
it is. Here we're looking at the software's efficiency.
Yeah.
Key metrics are uptime, transaction times, error rates.
Like how long a page takes to load.
Exactly. Or the number of HTTP requests and how long they take, API response speeds. This is where tools like Datadog and Splunk really shine because they can connect the front-end user experience to what's happening on the back end.
Okay, so that leaves the connective tissue and the human element. What are the last 2?
Third is network monitoring. This is all about connectivity and security. Your firewalls, load balancers, VPNs. You're measuring things like network traffic, bandwidth, latency, simple things like pings even.
And the last one?
The last one is maybe the most interesting, user behavior monitoring. This is totally different. It's not just about whether the server is on, it's about the overall customer experience. We're tracking how people are actually using the app, their click paths, time on screen, how they interact with new features.
You're moving beyond just technical logs and into actual business functionality.
You got it. For an e-commerce site, you'd track the checkout flow. For an education app, you track progress. You're correlating the technical performance with the user's actual journey because at the end of the day, their subjective experience is the only thing that really matters.
So putting it all together, we have these 4 categories. If an organization wants to do this right, what are the best practices for setting targets across this whole landscape?
It's about synthesis, really. You have to pick targets that give you comprehensive visibility. The best practice is to make sure your targets cover 5 key areas: server health, application performance logs, system vulnerabilities, development milestones, and finally, that user activity and behavior. If you're covering those 5, you've pretty much achieved the visibility you need to move fast without breaking things.
Let's get into the mechanics of it, the how. What are the essential features a monitoring tool absolutely has to have to be effective?
Right, the tool itself. Well, first and foremost, it needs to be real time. We're talking high-speed streaming data. And it needs smart, configurable alerts that can trigger on anything from hardware issues to weird application behavior.
And what about the sheer volume of data? I mean, it must be a tsunami of logs.
It is. So the tool needs automated log aggregation and really powerful analytics. You have to be able to query the system's health on demand. And crucially, it needs what we call post-mortem capability. You have to be able to do a historical replay to visualize exactly what led up to a failure. That's key for the remediate part of the cycle.
Okay, now this is a big one. Let's talk architecture. I hear a lot about push versus pull mechanisms for collecting data. What are they, and what are the trade-offs when you're trying to do this at a massive scale?
This is a fundamental choice. It's about how a metric gets from the thing being monitored to the central collector. In a push mechanism, the system being watched has a little agent on it, and that agent periodically sends or pushes its data to the collector without being asked. In a pull mechanism, it's the other way around. The central collector is the one in charge. It periodically requests or pulls the data from each system.
That feels like a huge architectural difference. Can you give us an analogy to make that clearer?
Sure. Think of a busy restaurant kitchen.
I like it.
A push system is like every single chef. the grill station, the salad station, automatically sending a status update to the head chef's dashboard every 30 seconds.
Whether the head chef asks for it or not.
Exactly. A pull system is like the head chef having to walk over to each station every 30 seconds and ask, hey, what's your status? How many orders are you backed up on?
The push model sounds a lot easier for the person in charge, for the collector.
It is, for discovery at least.
Yeah.
The collector doesn't need much setup. The agents just start sending data. And it's very distributed, so it scales easily as you add more servers.
But what's the catch?
The catch is flexibility. With push, you're usually stuck with whatever metrics the agent is pre-programmed to send. You can get bottlenecks if 1,000 systems all try to push data at the exact same time.
Okay, so pull solves that.
Pull gives you way more flexibility. The collector is in charge, so it can ask for any metric at any time. The trade-off is more management overhead. The collector needs to be constantly updated with where to find all the agents, and if that one collector has to make 1,000 requests really fast, it can become a bottleneck itself. It's a really important choice.
Let's make this super concrete. You mentioned Nagios earlier. How does a tool like that actually embody this whole cycle of observing and alerting in practice?
Nagios is a classic, powerful example. It monitors your entire infrastructure systems, apps, services, you name it. It's built on a serverless architecture, and the Nagios server runs the key part, which is the process schedule.
And the plugins are what do the actual work.
The plugins are the workhorses, yeah. They're little scripts that go out and check on a specific thing like database response time or disk space. They get the result, send it back to the scheduler, and if a number crosses a critical threshold, bang. The system sends out an alert, web interface, SMS, email, whatever you've configured.
So it's not just about detecting a crash. It often has the ability to respond built in.
Yes, that's a key feature. A lot of systems are configured to automatically trigger scripts to try and fix common problems. Restarting a service, scaling up a resource. That combination of passive watching and active automated response is what makes the monitoring continuous. It's what keeps those TTD, TTM, and TTR metrics as low as possible. So when you pull it all together, when you adopt this kind of comprehensive monitoring, the benefits go way beyond just the IT department. You get better security from automated checks, you catch performance errors way earlier, and you just drastically reduce system downtime.
And the customer feels that immediately.
Immediately. It leads to a better user experience, less frustration, and that builds business credibility. It's not just about looking at logs, it's the core mechanism that lets a digital business handle the relentless pressure of constant change.
It really is that high-speed feedback loop, isn't it? The operational nervous system that lets everything else move at lightning speed, constantly sensing, analyzing, and self-correcting. Which leaves me with a final thought. If continuous monitoring is so vital for finding issues in complex code and infrastructure, with its real-time feedback, automated alerts, and measuring the impact on the end user, what would an equivalent continuous monitoring system look like for other complex systems, like, say, organizational or even political systems? What would the time to detect metric look like for an ineffective policy? And who gets the automated alert? That is a deep dive for another time.